One of the most important rules that we will discuss for taking derivatives is the chain rule. The chain rule allows us to take the derivative of composite functions. We've learned how to take the derivatives of power functions and how to take the derivative of rational functions, different types of functions. This will allow us to take the derivative of any type of composite function using the rules we've already learned. What this rule tells us is that rates of change multiply. The derivative of f of g of x is the derivative of f at g of x times the derivative of g at x. That can be written in two different forms. The top form, f of g of x, the derivative of f of g of x is f prime of g of x times g prime of x. And sometimes it's easier to use it in Leibniz notation. dy dx is dy du times du dx. That means the derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to x. We're going to use that notation in our next example. We are going to identify what our y function is in terms of u and what our u function is in terms of x. This is an example of a composite function. You'll notice we have learned how to take the derivative of 3x squared plus 1, and we've learned how to take the derivative of x squared. This function puts those two functions together. We have 3x squared plus 1 inside of our squared function. So we are going to say u is 3x squared plus 1. That is the inside of our function. That means we have a function u squared. Now if we use the Leibniz notation, dy dx is the derivative of y with respect to u times the derivative of u with respect to x. Then we will look at this y function. And remember, the derivative of u squared, if u is our variable, will be 2u. Make 2 our coefficient, subtract 1 from the exponent, times du dx. That means we're going to take this function and differentiate it with respect to x. So we bring the 2 to the front. 2 times 3x is 6x to the first power. And the derivative of 1, of course, is 0 since it's a constant. Now, we need to substitute back in u because our original problem did not have u, it had x. And so we plug our u back in. U was 3x squared plus 1. Now this can be simplified. First I'm going to multiply 2 times 6x is 12x times 3x squared plus 1, and distribute 12x times 3x squared is 36x cubed. 12x times 1 is 12x. So the derivative of 3x squared plus 1 in parentheses squared is 36x cubed plus 12x. Now, we don't want to have to do this, which they call substitution, every time. We don't want to have to go through all of the notation every time. So what we have to think about here is what is our outside function and what is our inside function. Our inside function is 3x squared plus 1. Our outside function is x squared. If we just had our outside function, which is x squared, we know that we find that by bringing the 2 to the front, subtracting 1 from the exponent. So we would have here 2 times 3x squared plus 1. But now what the chain rule tells us is we can bring the 2 out to the front, subtract 1 from the exponent, but we still have to take the derivative of the inside, which is 6x. So by doing that, we can leave out some of these steps. And that's what we want to try to do, is make this as easy as possible. Okay, let's take another example. We want to differentiate y equals sine of x squared plus e to the x. Now we've learned how to differentiate sine of x. We've learned how to differentiate x squared. We've learned how to differentiate e to the x. Here we have a composite. So what we want to think about is what is our inside function and what is our outside function. Now our inside function is going to be this, the x squared plus e to the x. our outside function here is the sine of x. Okay, so what our rule tells us when we take the derivative is we take the derivative of the outside function at our inside function. So the derivative of sine is cosine, and it's still at our inside function, which is x squared plus e to the x. But then we have to multiply that by the derivative of the inside, which is the derivative of x squared plus e to the x. So we take the derivative of sine at x squared plus e to the x, which is cosine of x squared plus e to the x. And then we multiply by the derivative of x squared plus e to the x. With the derivative of x squared, we make the two a coefficient. Subtract 1, we have 2 to the x. Remember, e to the x is that special function. The derivative of e to the x is just e to the x. You'll notice I left this in parentheses. If I did not put the parentheses here, then that would be saying that only 2x is multiplied by the cosine of x squared plus e to the x. But the entire derivative is multiplied by the cosine. And we can leave it this way, or we can write the derivative in the front times the cosine. Just remember that you cannot multiply the two parentheses together. This parentheses is part of the cosine. This is what we're taking the cosine of. Now another rule, this is just an application of the chain rule, says if we're taking the derivative of e to the u, that's e to the u times the derivative of u with respect to x. Well, this is still just the chain rule. Our outside rule is the e, our inside rule is the cosine x. So when we take our derivative, the derivative of e to the x is e to the x. So we will have e to the cosine x. But then we have to multiply that by the derivative of cosine x. Remember, the derivative of cosine x is negative sine x. So we have cosine x times negative sine x. And it might be easier to write that as negative sine x in front times e to the cosine x. That doesn't really matter. Now I want us to revisit an example from a previous recording last. Remember that we found the derivative of y equals e to the negative x. And we used the quotient rule. We wrote this as 1 over e to the x, and we used the quotient rule. By just applying this rule, all we have to do is say the derivative of e to the negative x is e to the negative x times the derivative of negative x. Now to find the derivative of negative x, I'm sorry, that's wrong. That should be negative x. The derivative of negative x. To find the derivative of negative x, we have negative 1 understood times x. We bring the 1 out in the front, so that will be negative 1. When we subtract 1 from our exponent, we have x to the 0, which is 1. So the derivative here is just negative 1, or negative e to the negative x. So by using the chain rule, we can find that derivative without having to apply the quotient rule.